Program. Sir, you are muted. You are still not audible.
This is 1O. Determine the equivalent resistance between the terminals A and B. Determine the equivalent resistance between the terminals A and B. Determine the equivalent resistance between the terminals A and B. Question. 8/3 is correct. You can arbitrarily take any battery here, equivalent resistance should be the same. Yes. I take 10. So if you take 0 volts here, this will be 10 volts and 10 volts. Yes. I took this to be X, this to be Y. Now, can you see that the current in this and this should be the same? Yes. Similarly, current in this and this should be the same. 10 minus y, 10 minus x. So this will be, here it is y minus 0. This will be 10 minus y. This will be 10 minus x. Yes or no? That makes your life simple. Ultimately, your requirement is I R equivalent is equal to V divided by I, 10 by I. How do I get the value of I? If you can tell me the current in these two branches, for which you will have to tell me these both. Or tell me the current X and Y. Tell me the current in these two branches. I'll get back I. Tell me X and Y. I'll get X minus 0 by 3 plus Y minus 0 by 1 is the current I, which I should substitute here. Now to get the value of X and Y should not be a problem for me. The incoming current here should be equal to the outgoing current here. Incoming current here should be equal to the outgoing current here. By chance, if somebody is not able to see that the current here and here should be the same, then they will take different variables here. Welcome. You will have one more equation. You will have incoming current here should be equal to outgoing current here. Just that your simplification becomes easy if you are able to recognize that these both will have the same current and these both will have the same current. The answer will turn out to be 8 by 3 ohms. I am not doing the simplification till the last step. Can I proceed? Find the equivalent resistance across AB. This banana. Hmm? R into root 2 plus half. Yeah. Root 2 plus half. Here you will split this into one part, this into one part. The upper part is an infinite series. How do you go about with that? I use it on the next page. I'm finding out between A and C. Between A and C, this will be R, this will be R. If here the equivalent resistance is X, this will be X by T. Between A and C, you people can see this is between A and C. Here, every building block decreases by a factor of half. Right? So this when you calculate RAC will be equal to R root 2. You obviously know what is to be done. These both are in parallel, that is in series with this. Right? The second part of it again is RBC. Now see, I am speaking about RBC between these two. RBC 1 by RBC is equal to 1 by R plus 1 by 2R plus 1 by 4R, so on and so forth. This will become RBC will become R by 2. RAB will be equal to RAC plus RBC. Add both of them, that should be your answer. Online, but you are absent. Can I proceed? In the electrical circuit shown, power dissipated in the resistance R and 2R at any instant after the switch is closed is 9 watt and 2 watt respectively. Power dissipated in R and 2R is 9 watt and 2 watt respectively at any instant after the switch is closed. At any instant after S is closed. Find the rate of increase in energy stored in the capacitor at this instant. Rate of increase in energy stored in the capacitor at this instant. rate of increase of energy stored in the capacitor du by dt at this instant.
Is the answer two?
6.
How much did you say?
Two.
No.
6.
No.
Oh, sorry. 3. Just a second. I'm just going to
I'll take the current through this to be I1, through this to be I2 after the switch is closed. Power dissipated through R, you have given me as 9. It will be I1 square R. So let me calculate I1. This will be 3 by root R. Agreed? Power dissipated through 2R you are giving me is 2. This will be I2 square 2R. I2 will be equal to 1 by root R. Yes or no? UC is equal to Q square by 2C. Your requirement is rate of change here. This will be 2 times 2 Q by C into dQ by dt. Now this I1 and I2 will turn out to be I1 comes here. This is I1 minus I2. Right? dQ by dt through the capacitor is I1 minus I2. See the smartness and simplification. Right? dQ by dt through the capacitor will be I1 minus I2. You know I1 and I2. How will you get Q by C? Q by C is the potential difference across this, which should be equal to the potential difference across this. Q by C will be I2 into 2R. dQ by dt will be equal to I1 minus I2. Substitute I1 and I2 in this equation, you should get 4 watts.
just apply work energy on the entire system.
So there again.
Work done by battery is equal to power through R plus energy being added to the capacitor. And then apply KVL on the smaller flows to get V in terms of R.
Not an issue. Fine, perfectly. Can I proceed?
Yes, sir.
Circuit shown consists of three resistances and a bulb, a switch, and a battery. If the bulb glows equally bright, whether the switch is closed or open, write down this statement. If the bulb glows equally bright, whether the switch is closed or open. If the bulb glows equally bright, whether the switch is closed or open, find the resistance of the bulb and the voltage drop across it. Find the resistance of the bulb and the voltage drop across it. Key catch here is, first of all, I'll take this to be Y and this to be X. There is current flowing through it when the switch is open. But suppose when the switch is closed, you are telling me even when the switch is closed, the bulb is glowing with the same intensity. That is what makes the problem typical. This is 90 ohms, 180 ohms, and 90 ohms. Now this is a short circuited branch. In a short circuited branch, if current comes this way, nothing will go into this. Everything will go into this. If current comes this way, nothing will go into this, everything will go into this. So current must come this way. In this case, current has to go this way because whatever current comes into this branch has to go because this is open. But once I have short circuited that, whatever current coming in will not go into this branch, it will go into this branch. But instead, you are telling me this is glowing with the same intensity. Now, current must be going in this particular direction. That's the only possibility. Is this point clear? In that case, now this will be Y, this will be X. And why will this be Y and X? Potential difference should be the same because it is glowing with the same intensity. Now your life will become simple. Now have a look at it. This is 0. This is 54. 54. This current should be equal to this current. This incoming current should be equal to the outgoing current. At this junction, I will apply 54 minus X by 180 incoming current plus Y minus X by the resistance of the bulb should be equal to X minus 0 by 90. This I applied here. Now apply here. Total incoming current should be equal to the outgoing current. 54 minus Y by 90 should be equal to Y minus X by resistance of the bulb. Now come over to this. This incoming current, whole of that should go into this particular branch. This is 54. This is 0. 54 minus Y by 180 should be equal to Y minus X by resistance of the bulb less Y minus 0 by 90. Now, I would suggest in the process of simplification, if you use X, Y, RB as three variables and simplify, you will be in trouble. Call whole of this as some variable called Z. Call whole of this as some variable called Z. Whole of this as some variable called Z. Now simplify, your life becomes simpler. Y minus X by RB, put it as some variable called Z. Eliminate Z, you will get X and Y. Once you get X and Y, nothing is difficult more in that question. Y minus X will be 6. Can I proceed? Circuit shows consists of two identical capacitors of 10 microfarads each, 1 mega ohms of a resistance, three ideal volt sources of terminal voltages 100 volts, 550 volts, and 200 volts, and three switches. Write down the last line. Find the amount of heat dissipated in the resistors. Find the amount of heat dissipated in the resistors.
Please make
After a
the battery
long
a bit more.
time. Pardon?
I think if you could make the battery such that the terminals could be identified.
Sure, it is.
Okay, first write down the question. We don't know. We are unable to understand what you are saying. First write down the question. Find the amount of heat dissipated in the resistor. In the resistor over a long time after all the switches are closed. Find the amount of heat dissipated in the resistor. There's only one resistor here. Over a long time after all the switches are closed.
So what are the polarities of the batteries?
Yeah.
Asking if you could make the terminals identifiable because thank you.
One 1.625 joules.
Work done by the battery will be delta U plus heat loss. If you are asking about heat loss, work done by the battery minus delta U. That's what is important. Now that this is closed for a long time, this is closed for a long time. If it is closed for a long time, the branch with the capacitor will become an open circuit. Now if this is 0, this will be 550 volts. This is 0, this will be 100 volts. This will be 200 volts. Agreed? Now I take this to be positive, this to be negative, this to be positive, negative. You know the charge on these both capacitors. Work done by the battery. Work done by the battery. Have a look at it. 10 into 450 less 10 into 350 into 550 minus 10 into 450 into 100 minus 10 into 350 into 200. This will be the work done by the battery. Convince yourself about this. And delta U will be half into 10 microcoulombs into 450 square minus half 10 microcoulombs into 350 square. Subtract the two, it will be 1.625.
Check.
ड्रॉप नहीं होगा तो because बीच में resistor भी है 550. What is he saying?
He's saying that the charge is only 550. Not possible.
No, but in steady state there will be no current flowing through this. So potential drop across this will be 0.
So the capacitances were given as 10 mu farad, right?
Yeah, 10 microcoulombs.
Correct.
Microfarads, sorry, my bad. 10 microfarads. Here also I wrote micro. My bad. So first, if you people observe the first step, we calculated the work done by this battery for the charge on these two plates. How much charge went through the battery is what is done here. How much charge went through this particular battery for this charge is done here. How much charge has gone for this charge? How much charge has gone through this particular battery is done here. Failed to detect your microphone, you're doing something wrong. Ramesh. धर्मेश कुछ तो गड़बड़ है.
So
Put the problem because let them resolve. Now are you people able to see the board?
So,
Yes, sir.
Tell me when I can proceed.
So why did we take minus in delta U?
you please.
Should be plus. Why my mistake?
Okay.
A resistance coil wired to an external battery is placed inside a thermally insulated cylinder. Thermally insulated cylinder fit with a frictionless piston and contains an ideal diatomic gas. Ideal diatomic gas. A current of I is given to be 200 milliamperes exists in the coil, which has a resistance of 350 ohms. Resistance of coil. If the pressure of the gas remains constant, pressure of the gas remains constant, what should be the velocity of the piston in centimeters per second? Find the velocity of the piston if the pressure of the gas remains constant.
It's mass of what? M is mass of
Mass of the piston.
piston.
M is mass of the piston.
Ah.
Piston mass is 10 kg. First step will be power dissipated by the coil will be I square R. This I square R will turn out to be 14 watts. This 14 watts you will equate it to NCP dt by dt. This turns out to be N 7R by 2 into dt by dt is 14. Now you get N R dt by dt is equal to 4. This is my first piece of information. I need to go to the next slide to complete the problem.
So
So is the answer 4?
No. Now you have to apply work energy theorem. And you will require this information. The piston has got mass. Don't forget that. Piston has got mass.
The answer is 2.
Yes. Now when you write the work energy theorem, work done by the gas plus work done by the atmosphere, atmospheric pressure plus work done by mg should be change in kinetic energy. N R T T quite obviously minus P atmosphere into A into dx work done by the atmosphere minus mg into dx should be equal to 0. Now this should help you solve the remaining part of the problem. I'll take these both to the right, divide all throughout by dt. dx by dt will be velocity. nr dt by dt is something which I know. P atmosphere into A plus mg into dx by dt. You are asking me dx by dt. You know already this particular value. Should not be difficult. It turns out to be 2 centimeters per second. Can I proceed? Ten ohms, 5 ohms, 5 ohms. This is X. This is 10 volts. maximum power dissipated through the unknown resistance is to be found out. Maximum power dissipated through this. Maximum power dissipated through the unknown resistance.
Five by three. Oh, sorry. 520, sir. 520.
The problem is easy, you should be able to solve. For maximum power through this, what should its resistance be? What should the value of the resistance be? This is 10, this is 5, and this is 5. These both are in series. X ka value will be 5 into 15 divided by 5 plus 15 ohms. This should be the resistance for maximum power through it. Once I know the resistance, finding out current through that will not be difficult.
So could you repeat once again, please?
Maximum power through this के लिए the resistance of this. What is maximum power transfer theorem? If I have a battery like this and I give you resistance R, maximum power through this will be when this is equal to this. So I found out R equivalent across this. So technically this is R equivalent. X should be equal to R equivalent for maximum power through that.
Yes, sir. Thank you, sir.
Once I know that resistance, find out the current through it, you will get the maximum power. One specific clarification in maximum power transfer theorem. Suppose I tell you this is 10 ohms. This is the unknown resistance X. What should be the value of X for maximum power through X? It should be 10. For maximum power through X should be 10 ohms. For maximum power through 10 ohms, X should be how much? 0. Be clear about it. If the resistance is already fixed, I will be, I square R will be the power through this. I will be maximum when X is 0. So please verify which are they asking for. Maximum power through the variable X. X will be equal to 10. Maximum power through 10 ohms. X will be equal to 0. The difference should be very clear. Don't misinterpret maximum power transfer theorem. We'll have an early short break of 10 minutes, right? I'll come back in 10 minutes. We'll continue with this in 10 minutes. I'll come in detail. Take it. SBT 58 question. 50 ohms, 10 ohms. Forty ohms, 160 ohms, 10 ohms. A, B, C. This is 50 ohms. They asked you RAB upon RAC.
That middle one.
160, 10, this one, 200 ohms. It's a simple question, don't amplify. Just that numbers are not very convenient. Numbers are very uncomfortable. The numbers. RAB you will get 2380 by 29. RAC you will get as 82. No big deal in the problem, just that he made it look a bit different. When you are calculating RAB, these both are in series. That's in parallel with this. That's in series with this. And the remaining problem will be done. Suppose you are calculating RAC. This branch is an open branch. You are calculating RAC. This branch will be an open branch. Right? RAC. This branch will be an open branch. Right? Balance you will calculate and substitute there. The resultant calculations are not very comfortable. Agreed. All resistances are identical. When a 5-volt supply is connected across AB, the current in the branch CG is 3 milliamperes. The current here is 3 milliamperes. All resistances are identical. Find RAB. Find RAB. All resistances are identical. When a 5-volt supply is connected across AB, the current in the branch CG is 3 milliamperes. Find RAB. Problem is not that difficult. I'll give you one hint. The symmetry, if this is 3 milliamperes, this will be 3 milliamperes. We use symmetry there. Now think of it. If you take I current in this, I current in this will be 3 plus I, this will be 3 plus I. This I and I will come here as 2I. If this is 3 milliamperes, 3 milliamperes. So how do you put RAB as? RAB is equal to 5 divided by 2 times 3 plus I. If you can tell me the value of I, my job should be done. Agreed. How will I tell you the value of I? See the potential difference across this. 3 and 3. 3 into 2R should be equal to the potential difference across this. These both points have taken. Potential difference across this should be equal to the potential difference across this branch. This will be I into R. All resistances are identical. 3I into R. R and R will go. I will be equal to 2 milliamperes. Substitute here. 5 divided by 5 milliamperes. Remaining simplification, I leave it to your fine judgment. Can I proceed? All three ammeters resistance. All three ammeter resistances is 1.9 into 10 raised to minus 3 ohms. Reading of A2 is what is asked. All three ammeters A1, A2 and A3 are ideal and ammeter A3, sorry, one correction. A1 and A2 are ideal. A1 and A2 are ideal. A1 and A2 are ideal. A3 resistance is this. Resistance A3 is 1.9 into 10 raised to minus 3 ohms. Find the reading of the second ammeter A2. So I have taken the polarity correct. U is more of the yeah, polarity is correct.
34 by 27.
What?
34 by 27.
34 by 27. The problem is a catchy problem. We'll start with 0 volt here. Let's change the color. 0 volt. What will this be? 0 volt. Why will this be 0 volt? Ammeter is ideal. Resistance is 0. Right? I'll take this as X. If this is 0, this will be 0 volt. So despite the fact that E3 has got resistance, the current in it will be 0. That's the first hint. Right? Now, if this is X, what will this be? X minus 10. If this is X, what will this be? X minus 20. Great. This will be minus 8. This is 0. This will be minus 8. Hope I have taken the correct polarity. Perfect. Iska resistance you have given as 1.9 into 10 raised to minus 3 ohms. Right? Now apply KCL to the junction B. At this particular junction, incoming current should be equal to the outgoing current. You get the value of X. Once you get the value of X, I don't think remaining will be a problem for you. How much will that be? Minus 8 minus X by 3 plus 0 minus X minus 20 by 15 plus 0 minus of X minus 10 by 5 should be equal to 0. Simplify that. I am not doing the simplification, I just copied the answer. Now, if I2 current is coming in this, no current goes in this branch. So whole of I2 should go in this branch. If I2 current is coming in this branch this way, no current goes into this branch. So whole of I2 is going into this branch. Calculate the current in this branch from X. That will be your value for I2. 34 by 27 amperes. 34 by 27 amperes. Can I proceed?
Yes.
This is a source. This is R. This is R. This is 2R. Positive, negative. Charge supplied by the source varies with time as AT minus BT square. Find total heat produced in the resistor 2R. Find the total heat produced in the resistor 2R. Heat produced in the resistor 2R. Charge produced by the source is this. Charge produced by the source is this.
Time is given till how long it is.
That's the catch in the cup.
So is it 2 r a cube by 9b?
Wait, how much?
2 r a cube by 9b.
RA cube by 27B. RA cube by 27B is the answer. RA cube by 27B. Once upon a time, available snake, it's severe. Paradigm shift, SBT pathfinder. Still, this is not sufficient. Serious as a business. Actually, it takes the students for a while. Is not testing the concept of the student, the presence of mind of the student. Sometimes we feel we are writing and playful examination. Basically, Q is given as how much? 80 minus BT square. Current will be dq by dt. A minus 2BT. Now, if this is the current, you know how the current splits in the two. Inverse ratio. This will become I by 3. This will be 2I by 3. You know how the splitting happens, right? I by 3 matlab A minus 2B by 3. When will this become 0? T is equal to A by 2B. This is the time after which the current through that will become 0. Because what he is telling you, The source is sending this amount of charge. It is not a constant current source. It is not a constant voltage source. Source is sending this amount of charge. So till when will it be existing? Now if I call this current as I2 just for my convenience, integral of I2 square 2R dt 0 to, I'll call this T naught, should be my answer. Thereafter it will not be a trouble for you people. This is just playing with words. In the examination, under pressure, it's easy to take anybody for a ride. Conveniently sitting here, it will not be difficult for us to figure it out. But what he meant here is, he's sending this amount of charge. It is not a constant source, constant current or voltage source. Ille. Can I proceed?
Yes, sir. Yes, sir.
One second. Not a big deal, but okay. In steady state, find the charges on 5 and 10 microfarad capacitor. In steady state, find the charges on both the capacitors. There are only two capacitors, 5 and 10 microfarad. Problem is not difficult, it's quite easy.
Right. Right.
One second here, just solve this. I'll be back in 2 minutes.
650 by 7, 900 by 7.
650 by 7 is on 5 microfarads. 1900 by 7 is for 10 microfarads. For 5 microfarads, it is 650 by 7. For 10 microfarads, it is 1900 by 7. Technically, this will go. This will be an open circuit. कितना था यार? 20 volts. Technically, this will go. This will be an open circuit. Now, if I take I current in it, I am taking I current here. I'll take X current here. I minus X will be here. You will get X current here. This is I minus X. This is I. This is I. See if you are convinced. This will be I minus X. This is X. Right? I'll get back I current here. This is open. So whole of I current should come here. If this is X, sorry, this is X, this is I minus X. This is open circuit. Whole of this I minus X will come into this branch. Balance should not be a problem. It is just playing with Kirchhoff's voltage law. What sense does that make when we increase 4 for resistors, 5 capacitors? That's problem for the sake of problem. Yeah, John. Oh, 15 pages. Share. QR code. Share. Please wait. Have a look. You have a 4 ohm resistance here. 4 microfarad capacitor. 4 ohm resistor. 4 ohm resistor. 4 microfarad capacitor. 4 ohm resistor. 2 microfarad capacitor. $25. 4 ohms. 2 microfarad capacitor. Hope I didn't miss anything. 4 microfarad. This is 4 and 4. This is 4 microcoulombs. 2 microcoulombs. 4 ohms. 25 volts. And a switch, yes, 4 ohms. The capacitor C shown in the figure is charged by closing the switch. Capacitor C shown in the figure, right? C is 2 microfarads. Find the charge on it in steady state. Find the charge on this 2 microfarad capacitor in steady state. Find charge on the 2 microfarad
I
capacitor in
think you had
steady
given
state.
the same question in the assignment.
I've given, is it?
In the assignment, huh? The same question is there.
Okay. You have already solved it?
Yes, sir.
Fine. Then skip this. We go to the next. Wait. Solving all this when we see the PYQs of JEE mains, feel very happy. It's as though it's a cool breeze. Unless they give a wrong question. Each capacitor is of capacitance C. Find the equivalent capacitance across AB.
Then this.
Done. Then we are going to repeat problems. It seems you people have already done this.
Yes, sir.
And fine. Do one thing. We stop here. Current electricity magnetism in this half an hour. I don't think I can start and do any just destroy. Right? But one thing. Have you done the potentiometer experiment in the lab? Potentiometer, they'll ask you questions. In the lab, if you have done it, you're safe, right? Both in your practical examination as well as theory, they'll ask you questions on it. Potentiometer, please have a look at it. Verification of Ohm's law, potentiometer. Something else I about to say that this phone call disturbed me. Lost track. Fine. We are done with current electricity. Next class we'll start with magnetism and EMI. Right? Magnetism may have you done these 3 experiments of tangent galvanometer? Done in the sense theoretically. Okay, then remind me next class. First, I'll start with that experimental part. Tangent galvanometer, deflection magnetometer, oscillating magnetometer. These 3 are there for your JEE mains, not for advanced. These 3 practicals are there for your JEE mains. You should know what this practical is and how JEE mains people took you people for a ride in that. I'll let you know it was the silliest possible thing. If you know how to do the experiment, the job will become much easier. So next class, first remind me, I'll start with the 3 experiments and then we'll go into magnetism. Today we are stopping a bit early. I have a small emergency job, right? I'll try to stretch on for another half an hour in the next class while dealing with magnetism. Magnetism EMI is long enough as well. Okay.
Yes, sir. Thank you, sir.
See you people in the next class. Good day.
Thank you, sir.